Today we're going to do lesson 7 from module 3, where we're going to be using our fraction understanding of adding and subtracting fractions in a word problem scenario. So, number 1 says, Christine baked a pumpkin pie. She ate 1/6 of the pie. Her brother ate 1/3 of it and gave the leftovers to his friends. What fraction of the pie did he give to his friends? So let's look at our important information. We know that she baked a pie. So if this represents our pie, we'll start drawing it out. She ate 1/6 of the pie. So we're going to ignore our proportions here. And we're going to say that that's 1/6. And this is, let's just say Christine. So she ate 1/6. Her brother ate 1/3. So we'll say this 1/3 of the pie was her brother. And we know that there were some leftovers that went to his friends. So we'll call this the friends. And this was the leftovers. The question they want us to answer is what fraction of the pie did he give to his friends? So they want us to know this question mark here. So we have to think about the fact that this whole thing is the one pie. They didn't give us anything else besides the fact that it was just the one pie. So we know that combined together, Christine ate 1/6, the brother ate 1/3, and then the rest of it went to his friends. So we can figure out how many went to his friends by doing some addition and some subtraction. So we can add 1/6 and 1/3 together to figure out how much did Christine and her brother eat, and then we can think of what the leftover is. So we want to add up 1/6 and 1/3 to figure out then what's going to be left over. So adding 1/6 and 1/3, we're going to do with our rectangular fraction models. So Christine ate, here's the 1/6. Her brother ate 1/3, which looks to be quite a bit more than what Christine ate. And we need to find common denominators, just like we normally would. So I'm going to do that by splitting up my fraction models. My 1/6 is now going to be split into thirds. And my 1/3 is going to be split into sixths. So my new fraction of common denominators is going to have a denominator of 18. And I know that because I have 18 pieces now in my model. I also know that because I have a 6 and a 3. And so 6 times 3 is 18. So 18 should be my denominator. 1/6 is now 3/18 because I times by 3, and I have 1, 2, 3. And my 1/3 becomes 6/18 because I times by 6, and I also have 1, 2, 3, 4, 5, 6. So now I have 3/18 plus 6/18. And added together, that gives me 9/18, which I can simplify and make that 1/2. Because 9 divided by 9 is 1, and 18 divided by 9 is 2. And I just wanted to simplify it to make it the easiest way possible. So Christine and her brother ate 1/2 of the pie. If they ate 1/2, if this right here is equal to 1/2, I can figure out what's left over, because if they ate half, I should have a half left. But I can do that mathematically because I have one pie and I'm doing 1 minus 1/2. Well, I can rewrite 1 as 2/2. So 2/2 minus 1/2 does give me 1/2. So there was 1/2 of the pie went to his friends. Because that is what the question is asking. What fraction of the pie did he give to his friends? So he gave 1/2 of the pie to his friends. Okay, the next question. Question number 3. Tiffany bought 2/5 kilograms of cherries. Linda bought 1/10 kilograms of cherries less than Tiffany, okay? Linda is 1/10 less than Tiffany. That's really important. How many kilograms of cherries did they buy altogether? How many kilograms of cherries did they buy altogether? Well, altogether is telling me I'm going to add. And I'm adding them together, which means I'm going to take Tiffany's plus Linda's, and that's going to give me the total amount of cherries. Right now I know how many cherries Tiffany bought, but I don't know how many cherries Linda bought. I need to figure that out so I can find the total. So if I think of this as Tiffany's, and Tiffany bought 2/5 a kilogram of cherries, I could think of Linda. Linda, I know, bought less cherries than Tiffany's. I know that because I see that word less in here. She bought a smaller amount. So it's going to be a smaller box. How much smaller, they also tell me too. Linda bought 1/10 a kilogram of cherries less than Tiffany. So this, from here to here, in this imaginary box, is going to be 1/10. Because I would have to add 1/10 to Linda to get to Tiffany. So if I can see that Tiffany's equals 2/5 of a kilogram and Linda's is something plus 1/10, I need to figure this out. And I can do that by doing subtraction because Tiffany bought this 1/10 more. So Linda's then is 2/5 minus 1/10. And I can do that with a fraction model. So I'm going to do 2/5. 1, 2, 3, 4. And then I can do 1/10. Ooh, I made these way too big. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to pretend they're the same size. So I need to find common denominators. I'm going to split these fifths into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to split these tenths into fifths. 1, 2, 3, 4. Okay, now for my denominators. It's really hard for me to count because it's so small, but I know my common denominator here is going to be 50. And that's because I have a 5 and a 10, and 5 times 10 is 50. So I'm timesing by 10, and I'm timesing by 10 because I had 2 rows. So that means this is 20. 2/5 equals 20 50ths, and 1/10. I'm going to times by 5, times by 5. So I get 5 50ths, and I can see that one. 1, 2, 3, 4, 5. So my new equation is 20 50ths minus 5 50ths, which gives me 15 50ths. 15 50ths I can simplify because they're both divisible by 5. So I can divide my numerator by 5 and my denominator by 5. So I can get 3/10. Because 15 divided by 5 is 3 and 50 divided by 5 is 10. So that means Linda is equal to 3/10 of a kilogram. Now, that's not my final answer because my final answer is how many kilograms of cherries did they buy altogether? So I'm going to make some room here to do that math. Because altogether, this means I'm going to be doing my... I'm going to be doing my addition now. And I'm doing Tiffany plus Linda. So Tiffany is 2/5. Actually, I want that in black. Tiffany is 2/5 plus Linda, which is 3/10. And I need to figure out that is going to be my total. And I can find a common denominator with these. I can use my rectangular fraction model and figure this out. Again, it's 5 and 10ths. You might see an easier way of doing this too, and that's fine. You can do it that way. I'm going to continue doing it with rectangular fraction models though, so I can be consistent with you. So this is 2/5, and this is going to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, space that better. There's going to be 3 of them. And now to find common denominators, we're going to split this into tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9. And split this one into fifths. Okay. Now I can tell my new common denominator is going to be 50 again. And I know that because I have a 5 and a 10. So if my new denominator is 50, that means I'm timesing by 10 and by 10. So 2/5 become 20 50ths. And 3/10 is going to be times 5 times 5. And so that's going to be 15 50ths. So I have a double check with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now I have 20 50ths and 15 50ths. And when I add those together, I'm going to get 35 50ths. I think I can make that fraction a little more happy by doing some division and simplifying it. I can see that both of them are divisible by 5. So 35 divided by 5 is 7. 50th divided by 5 is 10. So it looks like 7/10 kilograms of cherries is what they were able to purchase all together. Now, I know I mentioned this, but I was doing rectangular fraction models for these problems, even though the numbers are getting bigger and bigger. And you can kind of see how it gets more and more challenging to do models with bigger numbers. And we can always use the models, but there are different strategies you can use to find those common denominators. If you work on that right now and you have a strategy that works for you that's just numeric, that is fine. You can do that method. But if you prefer the fraction models, that's why I'm modeling that way for you, so I can be consistent with you. And in a couple lessons, we're going to work on just numerical. But right now, models are perfectly fine. And if you are doing it a different way without models, that also works. Okay, let's look at this last one. Ribbon A is 1/3 of a meter long. It is 2/5 of a meter shorter than ribbon B. What is the total length of the two ribbons? Okay, so ribbon A is 1/3 of a meter long. So this one reminds me kind of the one we just did. So I'm going to do this side by side models. So I've got ribbon A is 1/3 long. It is 2/5 of a meter shorter than ribbon B. So ribbon B, I'm thinking here, ribbon B, let me read that one again. Ribbon A is 1/3 of a meter long. It is 2/5 of a meter shorter than ribbon B. So it sounds like ribbon A is smaller. So that means ribbon B should be ribbon A plus 2/5. Because ribbon B is the longer ribbon. What is the total length of the two ribbon is the question mark. So they want to know what the together is going to be equal to. We can't figure that out until we do a little math. Because ribbon B is not just 2/5, it's really 1/3 plus 2/5. Because it's ribbon A plus another 2/5. So when I'm thinking about this, I have two options. I can either figure out ribbon B's length right now and then add it to ribbon A, or I can think about it and think that really the total is 1/3, because that's ribbon A, plus 1/3, because that's part of ribbon B, plus 2/5. And that will give me the total length because it's made up of those three pieces. And the reason I'm kind of drawn to doing it this way is because I can add 1/3 plus 1/3 together right now without doing any models. 1/3 plus 1/3, because it's the common denominator is already there, equals 2/3. So my new equation can be 2/3 plus 2/5. And now I only have to do one set of fraction models and I'll be okay. So I'll represent that right now. I can do 2/3. Plus 2/5. 1, 2, 3, 4. going to shade in 2 of them. And then I need to find my common denominator. I'm predicting it's going to be 15. And the reason I'm predicting that is because I have a 3 and a 5 as my denominators. But let's split my 2/3 into fifths. 1, 2, 3, 4. And let's split my 2/5 into thirds and see what my new fractions are. Oops. Sorry, I'm right on top of my page movers. Okay, 2/3 just became 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 15ths, because there's 15 pieces, which means I was right with my prediction. And 2/5 just became 6 15ths. So now my new equation is 10 15ths plus 6 15ths. Well, the 15 stays the same, and my numerator becomes 11, because 10 plus 6 is 11. So what I get for my total length of my 2 ribbons is that 11 15th meters is my total length of both of my ribbons combined. I love a good word problem, especially when we get to do models and really deciphering what they're meaning. I know it can be a lot of work, especially when I'm asking you to do models to show your thinking, plus rectangular fraction models. So hopefully you're able to take your time today and really decipher what these problems are asking. And we're able to use all of our knowledge of adding and subtracting fractions in our 2-step word problems.